Good morning, students. Today we'll study about the classification of elements and periodicity in properties, class 11th, unit 3rd, part 2. IUPAC nomenclature of elements with atomic number greater than 100. The following procedure is adopted by IUPAC. According to IUPAC nomenclature, the elements are named by combining the Latin names or root of the digits in the order in which they appear in the atomic number, and IUM is at the end. If digit is 0, Latin name is nil, abbreviation is N. For one digit it is un, Latin name, abbreviation U. For 2 it is bi, B is the abbreviation. For 3, digit 3, Latin name is tri, and T is the abbreviation. For digit 4, quad is the root, Q is the abbreviation. For 5, pent is the root, P is the abbreviation. For digit 6, hex is the root, H is the abbreviation. For digit 7, root is sept, abbreviation is S. For digit 8, root is oct, abbreviation is O. Digit 9, N is the root, E is the abbreviation. Now we take example of 101, 101. For 1 it is un, plus for 0 it is nil, for 1 it is un, and we add IUM in the end. The total the name will be unnilium, and the symbol of this element will be first U, it is capital, then N, small n, then this U is the symbol. We take another example for 105, 105. For 1 digit we'll write un, for 0 digit it is nil, for 5 we use pent, plus IUM. So name will be unnilpentium, and the abbreviation will be, the symbols first will be capital U, then N, then P. So we have 120 elements. We can write like this also. Now we classify the periodic table in the form of SPDF blocks. S block elements are those elements in which the last electron enter into s orbital. First two elements, first two groups are called s block. P block elements when the last electrons enter in the p orbitals. It's from group 13 to 18. From D block elements, it's from group 3 to 12, when the last electron enter into the d orbital. F block elements are those which are in which the last electrons enter into the f orbitals. S block elements. Elements in which the last electrons enters the s orbital of their outermost shell are called s block elements. Since the s subshell can have a maximum of 2 electrons only, so there are only two groups, group 1 and 2, in this block. General characteristics of s block elements. These are soft metals having a low melting point and boiling point. They are highly reactive in nature. Because of their high reactivity, they are never found in pure they never found pure in nature. They have low ionization enthalpies. They are electropositive in nature. Most of them impart characteristic color to the flame. They form mainly ionic compounds. P block elements. Elements in which the last electron enters the p orbital of the shell are called p block elements. Since the p subshell can have a maximum of 6 electrons, so there are 6 groups in this block, group 13 to 18. General electronic configuration of p block element is ns2np126. General characteristics of p block elements. Most of these elements are covalent in nature. Most of these elements show variable oxidation state. Tin shows +2 and +4 oxidation state. Most of the elements form acetic oxides. Ionization enthalpy of these elements are higher than S block elements. Most of these elements are non-metals. D block elements. Elements in which the last electrons enters the d orbital of penultimate shell, that is n-1 shell, are called d block elements. These includes the elements of a group 3 to 12 of periodic table. Since a d subshell can accommodate 10 electrons, so there are 10 groups in d block. General electronic configuration of d block elements is n-1 1 to 10, ns 0 to 2. These are called the transition elements because the properties of these elements are midway between those of most electropositive s block elements and the most electronegative p block elements. General characteristics of d block elements. They are hard metal having a high melting point and boiling points. Most of these elements and their compounds act as catalysts. They show variable valencies and oxidation state. Most of these elements form colored compounds. They have a tendency to form alloys with other metals. Most of the elements and their compounds are paramagnetic in nature. F block elements. Elements in which last electron enters f orbital of the antipenultimate shell n-2 shell are called F block elements. General electronic configuration of F block is n-2 F 1 to 14, n-1 D 0 to 1, ns2 F block block elements are divided into two series, lanthanides and actinoid series. Lanthanide series, the series consists of 14 elements, cerium to lutetium. In the lanthanide, 4f orbitals are progressively filled. These are also called rare earth metal elements since they occur in the earth crust in the negligible amount. Actinoids. These series consist of 14 elements from thorium to lawrencium. In actinoids, 5f orbitals are progressively filled. All the actinoids are radioactive elements. The first three elements, that is thorium to protactinium, uranium, occur in nature, but the remaining 11 elements from neptunium to lawrencium have been prepared artificially through the nuclear reactions. These elements, after uranium, are called transuranic uranic or transuranium elements. The F block elements are called inner transition elements since they form a transition series within the transition elements of D block. General characteristics of F block elements: they are heavy metals with high melting point. They show variable oxidation states. They form colored compounds. Most of these elements are paramagnetic. Most of the elements of the actinoid series are radioactive. Metals, non-metals and metalloids. Metals. More than 78% of the elements in the periodic table are metal. They are on the left hand side of the periodic table. Some important properties of metals are given below. Metals are usually solid at room temperature with a high melting point and boiling point. Exception: mercury is liquid at room temperature. The metal like gallium melting point is 303 Kelvin and cesium is 302 Kelvin, have a low melting point and are low melting solids. They are good conductor of heat and electricity. They are malleable and ductile. Non-metals. They are present on the top right hand side of the periodic table. Some of important properties of non-metals are neither non-metals are either solid or gas at room temperature except bromine, which is liquid. They have a low melting point and boiling point except boron and carbon, which have a high melting point. They are poor conductor of heat and electricity except graphite, which is a good conductor of electricity. These are neither malleable or ductile. Metalloids like silicon, germanium, arsenic, antimony, tellurium shows the properties both the metals and non-metals. Trends in metallic and non-metallic character. Metallic character increases from top to bottom in a group, while non-metallic character increases from left to right in a period. Periodic trends in physical properties. Atomic radius. It is defined as the distance from the nucleus to the outermost shell of the electron. Covalent types of atomic radii. Covalent radius. It is defined as one half of the distance between the nuclei of two similar atoms joined together by a single covalent bond. So if we see the formula of covalent radius, that is half of internuclear distance between two bonded atoms. If we take the example of hydrogen, the internuclear distance is 74 picometer. Half of the distance is the radius of the covalent radius of the hydrogen atom, that is 37. Similarly, the covalent radius of chlorine is half of the internuclear distance, which that is 198 upon 2, which comes to be 94. Covalent radius of chlorine is half of the internuclear distance, 198 upon 2, which comes to be around 99 picometers. Internuclear distance, see the covalent radius of hydrogen atom is given here. 74 is the internuclear distance, the distance between the two nuclei, and 37 is the half of the internuclear distance, which is 37 picometers. Van der Waals radius. It may be defined as one half of the internuclear distance between two adjacent non-bonded atoms belonging to the nearest neighboring molecule of the same substance in the solid. So van der Waals radius, you can see this is chlorine molecule, this is another chlorine molecule, this is the van der Waals distance, that is 360 picometer, and half of this is 180 picometers of van der Waals radius. Ionic radius may be defined as the effective distance from the center of the nucleus of the ion up to which it exerts its influence on the electron cloud. Thank you.